Hello, my name is Kristen Gutu, and this is the second episode of Technically Biased. Today's guest speaker is Meredith Broussard, who has her BA from Harvard, her MFA from Columbia, and is currently an NYU Associate Professor focusing on data-driven reporting, computational journalism, and data visualization. In 2018, she published her first book, Artificial Unintelligence: How Computers Misunderstand the World. More recently, she came out with her next book, which we'll be discussing on today's show. Meredith, can you introduce yourself?
Hi, thank you so much for having me. My name is Meredith Broussard. I am a professor at NYU in the Arthur L. Carter Journalism Institute. I'm also the research director at the NYU Alliance for Public Interest Technology. And I have a new book called More Than a Glitch: Confronting Race, Gender, and Ability Bias in Tech.
And I'm so excited to ask you about it. I loved your first book, Artificial Unintelligence, and in More Than a Glitch, I loved even more learning about the examples of biases we see being perpetuated in tech. You use the term technochauvinism a lot, and I think it could be helpful if you would please explain what that is.
Sure. Technochauvinism is a kind of bias. It's a kind of bias that says that technological solutions are superior to others. And what I would argue is that instead, we should think about using the right tool for the task instead of just defaulting to, we should use computers and that'll be better. So sometimes the right tool for the task is absolutely a computer. And sometimes it's something simple like a book in the hands of a child sitting on a parent's lap. It's not a competition. One is not inherently better than the other. It's about, again, the right tool for the task.
And in your new book, you reference Ruha Benjamin and how, quote, new technologies reproduce and exacerbate historical inequality while being portrayed as neutral or progressive. Benjamin writes that, quote, this is more than a glitch. It is a form of exclusion and subordination built into the ways in which priorities are established and solutions defined in the tech industry, end quote. My question is, how do we destigmatize this issue so that we get people to listen and act proactively without activating their defense mechanism, which is what I so often experience when I bring up the topic of bias in tech?
Yeah, absolutely. These are tough conversations to have. Ruha Benjamin's work and also Safia Noble's work were really major inspirations for me as I was writing this book. And I think that all of their work is just terrific to reference and to return to as touchstones while we are doing the work of working on our own unconscious bias, uncovering bias inside technical systems, and just becoming better allies and better people in general. But I think it's really important to acknowledge that these are hard conversations to have. And we're accustomed to having these conversations around technology where it's like, okay, what is the pain point? Let's identify the pain point. Let's narrow it down. Let's write code against it. And then let's scale the code. And then we're going to make $1 bajillion, right? That's the pattern. That's the fantasy. And it did work for a while. I mean, how well it worked and whether it's been good for us overall is debatable. But it was certainly effective in generating enormous wealth for a while. But we're at an interesting point now where all of the problems that were easy to solve using technology have been solved, right? And so we're at a more complicated place. And the social problems that have not been solved with technology actually can't be solved with just a technical fix. So we need more nuance in our discussions around these issues.
And going off of that, you bring up facial recognition technology and give a few examples of it. You say that maybe this isn't the way to go in policing or EdTech. Can you elaborate on this?
So I think that technochauvinism is relevant here again, because a lot of the decisions that have been made in policing and in EdTech around technology are driven by technochauvinism, are driven by the assumption that it's going to be better if we use more technology, the assumption that innovation equals using technology. And those are not safe assumptions. So with something like facial recognition technology, it's deeply biased. It's better at recognizing light skin than dark skin. It's better at recognizing men than women. It generally does not kind of include trans and non-binary folks in the training data at all. And so these systems have bias baked in. And so then when they get deployed in, say, policing, they are disproportionately weaponized against communities of color, communities that are already over-policed. So it sets up this really dangerous feedback loop where you feed the systems with biased data, then the systems make biased decisions, and additional surveillance and scrutiny comes onto vulnerable groups. Folks get misidentified, get involved in the criminal justice system unnecessarily. They incur enormous expense, disruption to their lives. It's a big mess, right? And the police are just wasting enormous amounts of money on technologies that don't work very well. Robot dogs, I think, are a really good example of this. There is a quadruped robot that people are very excited about, and they're like, "Oh yeah, it's definitely going to be really good for policing," and it's really just not. It's $150,000 of nonsense. In EdTech, we have similar decisions being made, spending public funds on technology that does not work very well. So automated test proctoring was something that people were very excited about during the pandemic. Well, it has all of the problems of facial recognition systems. So students with darker skin were having trouble getting recognized by these online proctoring systems. And when you are administering a test over the internet, connectivity really, really matters. And if a kid gets kicked out of a test during the test, then they lose valuable time trying to reestablish that connection. And it's really disruptive for kids because these tests are already very high stakes. And there just aren't as many. Connectivity is not as robust as people imagine, right? Like the whole technological system that we're operating within, it is a system. It's so much more fragile than most people imagine. And it goes down all the time in extremely inconvenient ways. And I really think that should not get in the way of kids' education.
Yeah, I completely agree. And I want to bring up Isabel Castaneda, but before we mention her, I do have another question about policing in our prison system, and I want you to touch a little on the COMPAS algorithm. But in addition to that, I think people overlook how layered this racism is. So there's this step where we misidentify people with facial recognition technology, but then there are algorithms like COMPAS that prime us on who we look for, and then on top of that, we are wrongfully arresting people. Are these people's reputations being expunged? Or are future algorithms building decisions, such as recidivism rates, based on this false data? Can you clarify how this affects people in the long run?
So that's a really good question. And I think that journalists should absolutely be following up on this question because when a policing system misidentifies somebody and that person gets wrongfully arrested, as in the case of Robert Williams, who was a man in Michigan who was wrongfully arrested as a result of a bad match by facial recognition systems. That record that's generated is not necessarily getting expunged. It really depends on the data retention schedules at that particular police department. It depends on the data retention policy of the facial recognition company that manufactures the software. There are a lot of factors. I generally tend to assume that whatever is the sloppiest possible option is the one that's happening, right? So gang databases, for example, are another thing that we need to keep an eye on, because police generate these gang databases because database technology is extremely mundane, right? You can spin up a database in less than 5 minutes. So if a police department is using a gang database, generally it's secret. So they're not publishing it. They're not releasing it through FOIA the way that Freedom of Information laws would allow us to get access to other data. But so if you're in a secret database, you don't know that you're in a secret database. And if you don't know you're in it, you don't know that you need to get out of it. And if it's a secret database, it generally does not have a data retention policy that's really well implemented. And so people can linger in these databases for a very long time and not know that they're tangled up in this particular subculture of the legal system.
You also mentioned this misconception that algorithms are built on this vast pool of data, but that it's actually oftentimes very small, very specific. Can you talk a little about this and maybe reference the skin cancer AI, which is totally not inclusive?
So a few years ago, Google built an app that claimed to help people understand skin conditions. And it was a machine learning app where you would either take or upload a photo of your skin and your skin condition, and then it would give you information about what it thought was going on with your skin. And people were very excited about this, but it was very quickly understood that the way that Google had fed this machine learning app was it had only fed it with images of skin conditions on light skin. And skin conditions look different on different colors of skin. So one of the things that's important for dermatologists is to look at skin conditions on different colors of skin so that they can effectively diagnose their patients. So it was not just Google's fault, though. I mean, it was definitely their fault, but it is indicative of a larger problem, which is that medical diagnostic systems in general are often trained mostly on images of light skin or people with light skin. And medical textbooks often have only images of light skin. And so it's actually hard for medical professionals to find images of what dermatological conditions look like on darker skin. There have been some advances in the past couple of years, but when I talked to medical professionals as part of the research for this book, they uniformly said, oh yeah, it's very difficult to find images that are not of people with lighter skin, right? So it's this colorism bias in the world, in these systems in general, and that gets transferred into the technological systems. And so I think that we need to be aware of this problem. And we need to not rush into a future where we start claiming that these machine learning systems that are fed on biased data are somehow better or more effective than the current systems that we have, because they're just as flawed as our current systems. Now, I should say that when I'm talking about machine learning systems, I'm talking about a very specific kind of AI. And the way that you build this kind of AI is you take a whole bunch of data, you put it into the computer, you say, computer, build a model. The computer says, okay, it builds a model. The model shows the mathematical patterns in the data. And then you can use that model to predict things or to generate things. So generative AI, which most people are probably talking about nowadays, generative AI, the way it works is you feed in a whole bunch of text or images, and then the model can generate new text or new images. With predictive machine learning systems, you feed in a whole bunch of data about what had happened in the past, and then the system can make predictions about the future based on what's happened in the past. Right? And those are, again, systems that encode all of the problems of the past.
And that's interesting you say that, because I have another quote from your book here. If we feed the model data about who has been given loans in the past, the model will continue to reject Black, Indigenous, and people of color applicants. In 2021, the markup showed that loan applicants of color were 40 to 80% more likely to be denied than their white counterparts. So again, can you share how systemic this all is and how these algorithms are carried down through generations and based on data that dates back from centuries ago?
Yeah, it's true. That's, you've just outlined the path of what happens. A data scientist, if they're not familiar with the history of financial discrimination in the United States, might say, all right, well, I have all this data about who's gotten loans in the past. I'm going to feed it into the computer, and then that's going to make me a model that I can use to predict who's going to be a good credit risk in the future. And in the case of mortgages, a mortgage is what you use in order to buy a house, and homeownership is a major way of building generational wealth. So if these automated mortgage approval systems are kicking out borrowers of color, what they're doing is they are perpetuating financial discrimination. They are perpetuating the history of redlining, of financial discrimination, of residential segregation in the United States. And that's not something that gets us toward a better world, right? So we just have to be keenly aware that algorithmic systems, unless you proactively put measures in place so that the systems work against their inherent bias. Just if you don't do that, then the systems are going to be biased. They're going to reproduce inequality, and they are going to decide that the rich people should stay rich and the poor people should stay poor, and they're not going to affect social change.
And something that I think is really interesting, and I'm going to circle back to one of your examples, is the origin of race science. So Charles Darwin argued that men are superior to women and whites are superior to non-whites. His cousin, Francis Galton, is the father of eugenics. And what I didn't know until recently was that Francis Galton's research was funded by his father, who made his money by selling weapons to support the slave trade. So now you're telling me that we have somebody making money off weapons to support the slave trade, and then they're funneling that money into research that says, white men are superior to all other genders, all other races. And now we see algorithms like what's happening in the NFL today. Can you talk about the NFL example you mentioned in your book?
Yeah, it's a little horrifying, isn't it? Like the deep history of racism and the way that bogus concepts of race have kind of ricocheted through history, like, and the economic force of them, it's horrifying. Anne Morning's work was really helpful to me in understanding this deep history. I would also point people to work by Evelyn Hammonds, who's an historian of science. And I mentioned before Ruha Benjamin and Safia Noble's work. So let's connect this to what's going on today. Well, we have the situation you mentioned where there was an NFL settlement where NFL players had gotten what's called post-concussion syndrome or post-concussive syndrome, which is basically brain damage that you get from being hit in the head a lot. And that's what you get from being a professional football player. It is a major hazard of the job. And, it's good that there is better helmet technology now that is designed to, help people get fewer concussions, but still, like, it's a job where you're bashing your head into stuff. So your brain is very vulnerable. So the NFL was involved in a lawsuit. Former players who sustained this kind of brain damage as a result of their work were awarded a huge pool of money. I think it was something like $7 billion. And then once the pool of money was allocated, they had to decide who got how much. And there was a formula used to figure out who got how much. Well, the formula, like a handful of other formulas in medicine, had what's called a race correction in it. And that race correction is often a form of racism. So Black players were calculated as starting at a lower cognitive point than white players, meaning that their lifetime earnings were calculated as being lower than the lifetime earnings of white players. And so Black players were getting smaller payouts from this fund. So it's an example of how a bogus biological concept of race gets embedded in a mathematical formula and then gets embedded in an algorithmic system that is calculating a value and valuing somebody's life. And it's literally saying that Black lives are worth less than white lives. So Black players did successfully identify this problem. They fought it successfully, and the payout structure was adjusted. But this is not an isolated incident. There are lots of other instances where race is used as a factor in medicine. It's used in the calculation of who is eligible for VBAC, for vaginal birth after cesarean. It was used until recently in calculating something called EGFR, which is the score that qualifies you for the kidney transplant list. So Black patients had to be sicker than any other kind of patient in order to qualify for the wait list for a life-saving organ.
We see intersectional identities playing a huge part in who is being targeted. And going back to Isabel Castaneda, you mentioned she's a straight-A student, speaks heritage Spanish, and the IB exam decided we're going to calculate your score algorithmically. Can you discuss how this impacted her and, in short, how rich kids are graded higher than poor kids and what this means?
This was a particularly egregious example of algorithms run amok. So this happened during the pandemic, when the International Baccalaureate, which is a very prestigious secondary high school diploma organization, decided that they couldn't safely hold the IB exams that happen near the end of senior year, which was a reasonable decision given, the stage of the pandemic at that time. But what they decided to do instead was not reasonable. They decided to use an algorithm to assign imaginary grades to real students. So they used an algorithm to predict what they thought a student would have gotten had the student taken the test that did not happen. Right? So when you parse it out, it's so absurd. I mean, we all made strange decisions during the pandemic, but this really stands out as a poor place to put one's faith in this particular algorithm. And so I explained earlier how algorithms work, or how machine learning systems work. Well, what happened here is the system that IB was using was fed with data about who had succeeded at what level before on these tests. And if you know anything about education statistics, the greatest indicator for educational success is wealth. Rich kids do better than poor kids in school. That is something that education researchers have found over and over and over again. It's not that kids have different abilities. It's that poverty interferes with educational attainment, which makes a lot of sense, because if your family does not have enough money, then you as a student have a lot of home responsibilities. You have a lot of caretaking responsibilities. During the pandemic, there were a lot of kids who didn't have internet connectivity at home, so it was very difficult to do Zoom school. There's so many problems. So this is the reality on the ground. And what the algorithmic system did for Isabel Castañeda and for many other students who were in her position of attending schools where most of the students are lower income, the algorithm predicted that Isabel was going to fail her Spanish exam, which is absurd because she's a straight A student and a heritage Spanish speaker. And so it was just an example of the algorithmic prediction being wrong, and B, like having this misplaced faith, and then also locking people into a particular destiny, saying economics is destiny, and that's not actually what we want out of education, right? If you're a kid who's working hard in school, that's supposed to be a path to a particular place, right? So if the algorithm is saying, oh yeah, you're not allowed to go there, you're not allowed to go to that particular place, that's not really helpful.
And you reference another algorithm that was using student scores to base the likeliness that they would become criminals. And I did my own study for my thesis, where I looked at how grades for students of different color by state fluctuate in relation to other variables. And what was interesting was that in southern states with a more prominent Black racism, we saw more Black students having lower math and English scores, being expelled and suspended at higher rates, missing class more often, etc. But then in the Dakotas and other states where we see a more prominent indigenous racism, we saw the same trends with indigenous students. So going back to what you said earlier, how does this all tie in where families don't have the resources they need, and instead of the government stepping in and helping them, we further compound these obstacles?
I mean, yeah, that's how it works. Like poverty is a major factor in in educational attainment. And how do you address poverty? Well, you don't address it with algorithms. You address it by getting people more money. Like that's the way to address the problem of people not having money, right? But our current Current thinking around capitalism and what have you just says, all right, let's build code instead of addressing the underlying economic inequality. And I think we need to complicate the issue. I think we need to stop thinking that we can just code our way out of any difficulty.
And for my final question on that note, you emphasize that malintent is not necessary for bias to be perpetuated, but that we need to do better. I think we often overlook the biases that are a result of the digital infrastructure. So can you talk about Y2K and Y2Gay and what happened in these situations?
I know Y2K is such a great label for a phenomenon, right? So I do write a lot about unconscious bias. We all have unconscious bias. We're all working every day to become better people, but because our biases are unconscious, we don't know that we're doing them, and so that is an inescapable fact. Another inescapable fact is that people embed their own biases in the technologies that they create. Right? Cathy O'Neill has said over and over again that algorithms are opinions embedded in code, because you have to make all kinds of small judgment calls when you're writing code. Those are all informed by your own opinions about the world, the things that you think should be the case. And when these algorithmic systems are created by small and homogeneous groups of people, they get these massive blind spots that are the collective blind spots of the creators. So what happened with Y2K is it's a play on words that is based on Y2K. So Y2K was a potential disaster. It didn't actually end up being that bad, but it could have been, because in the late 90s, people realized that computational systems only used 2 digits to represent the date. And it was an implied 19 in front of those 2 digits. And then when the calendar was going to turn over to the year 2000, all of the systems were going to break because they were going to reset and think that it was 1900, the year, not the year 2000. Right? So there was this massive effort to update code systems so that year was represented as 4 digits, not 2. And the reason that it was represented as 2 digits was that it was a method of conserving space, memory space, because memory used to be really expensive and you used to have to be really diligent about making your programs really, really small, because, again, memory was expensive. So that was Y2K. So Y2Gay was what happened when marriage equality was passed in the United States. And people realized, oh, wait, all of our systems are set up so that marriage in a computational system is something that happens between somebody who is gendered male and somebody who is gendered female. And so we now need to go in and update any system that has this rule in place to make it so that anybody can be married to anybody, which was, it's great that that update happened. And it is kind of surprising that that rule was in place, that marriage was between a man and a woman. But, there are all kinds of ways that that social ideas are embedded in computational systems. And so one of the other things that I read about in the book is the way that that changing notions of gender have required updates, because actually our computational systems, they often have these 1950s ideas about gender, and gender is often represented as a binary, not as a string. So a string would be like a string of text. A binary is just a 0 or a 1. And we do understand now that the gender is a spectrum. It's something that should be an editable field that people should be able to change privately. But that was not how computational systems were built in the 1960s. That was not the 1950s idea about gender. And so the way that, especially at schools, at places like universities, the core computing systems that contain student information were set up in the 60s based on 50s ideas, and they haven't been updated. So it's been a massive project for universities to update their systems so that students can update their pronouns and their gender, and that the computational systems are not perpetuating outdated ideas.
Well, Meredith Broussard, thank you so much for your time today. It was wonderful hearing you speak. I have so many more questions for you, as I'm sure our listeners do, but I hope that inspires everyone to go check out or buy the book, More Than a Glitch, Confronting Race, Gender, and Ability Bias in Tech. It's a great read.
Kristen, thank you so much for having me.
Of course, and I hope to have our listeners join us for another great episode next week with guest speaker Angela Saini, who will be discussing her latest book, The Patriarchs, The Origins of Inequality, or how it's known everywhere else in the world except America, The Patriarchs, How Men Came to Rule. Thank you, and have a great day, everyone.